Alright, hi folks. So what I'm going to do is I'm going to do the lesson today for 8.3, the notes, and I'm going to explain the theorems quite clearly, and I'm going to help you use these theorems and postulates in some proofs. So your objective, make sure you get this in your notes, is to correctly use the different theorems to prove triangles are similar. So we're not proving congruency, we're proving similarity. So there's some new theorems. We discussed a couple, or one of them today, and it was the angle one. And so what we're going to do is I'm going to explain these, and you just get the stuff in your notes, okay? So here's something you need to understand. First, you have to be willing to accept this statement for the similar triangle postulate. We remember that postulates don't have to be proved, they just pretty much make sense. It says this: if there exists a correspondence between the vertices of two triangles such that the three angles of one triangle are congruent to the corresponding angles of the other triangle, then the triangles are similar. Okay, and here's a visual rep of that. If triangle ABC and triangle XYZ, if A is congruent to X, B is congruent to Y, and C is congruent to Z, then the triangles are similar. Doesn't prove congruency, just proves similarity. Okay? So that's the explanation for this postulate, that if all three angles are congruent, then automatic similar figures. Don't have to prove that the sides are proportional, they just are. Okay, so we can say this if this is the case. Here's our if. If the corresponding angles are congruent, then the triangles are similar. Okay, so here's what we can say. A little extension of this. If they are similar, then I can say the sides AB and sides XZ, that side AB and its corresponding partner XY, the ratios of those two sides, will be the same as doing side BC. BC corresponds to XZ. They will have their ratios will be equal. And then AC, which is this one here, AC corresponds to XZ. So this must be XY. Sorry about that. No. Sorry, let me fix. Oh, I apologize. So BC is YZ. So BZ is YZ. And AC is XZ. So their ratios, they're proportional, but their ratios will be equal. Okay, we'll do a math problem later so you can see it, but that's basically what we can say. If this is true, the triangles are similar, and if the triangles are similar, their corresponding ratios of the sides will be congruent or equal to each other. All right, so here's the first theorem. Notice that these theorems will be used as often as you used side, 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 angle, side, all of the postulates for congruency. We're going to be using theorems for similarity, so you need to get familiar with them. The first one is angle-angle similarity theorem. And basically what it says is if two angles of one triangle are congruent to two corresponding angles of another triangle, i.e. if A is congruent to X and C is congruent to Y, then triangles are similar, and it's angle-angle similarity. Okay, so you got to put a similar on there. So you're going to use angle-angle similarity as your reason, just like you would use side-angle side or whatever. Okay, so angle-angle similarity is used most frequently. We're going to use it a lot. If we have two triangles congruent, then the triangles are similar. Period. Done. Okay, so that's the angle-angle similarity theorem. The next one is the side proportionality theorem. I'm going to stop here. If I'm going too fast, stop me, write everything down, and then press play and get started again. Okay? All right. So side proportionality theorem. It says, If three pairs of corresponding sides of two triangles have the same ratio, then the triangles are similar. And it's side, side, side similarity. That will be what you write in your proof. All right. So here I have triangle cow and triangle pig. Okay. Now, if I can prove that the three pairs of corresponding, so CW corresponds to PG. Okay. So CW corresponds to PG. And that's 6/12. Okay, 6 to 12. If that is equal to, they have to have the same ratio, so that should be equal. And let's do CO to PI. And that measurement is 2 to 4. So I got 6 to 12, which reduces to a half, and 2 to the 4, which reduces to a half. And the last pair, OW, corresponding to IG, and that measurement is 7 to 14, which reduces down to 1/2. This is true. All three sides, pairs of corresponding sides, have equal ratios. Therefore, triangle cow is similar to triangle pig through side, side, side similarity. Okay? So they're similar. Got that? All right. Last one is the side angle side similarity theorem, different from side angle side congruency. Okay, it says this: if two pairs of corresponding sides of two triangles, misspelled, let's fix that right now. I would be so embarrassed if some adult was watching this or some other teacher. All right, I did it again. Triangles, have equal ratios and the included angle between the sides are congruent, then the triangles are similar. Okay, so let me explain that. So you'll notice that I have triangle tag and triangle U. Triangle tag and triangle U. All right. And here I have a side that's marked and a side that's marked. The angles are marked congruent and these sides. Okay, so it says if two pairs of corresponding sides of two triangles have equal ratios, so TA and YU, or YO, so TA over YO should equal AG and OU, AG and OU. That should be a true statement, and that'll give me the side and the side part of my side angle side similarity. So that's AG and OU. So I have to, if I'm going to use angle A and angle O, they have to be between these two pairs of sides. So TA and AG, they share A, so angle A is included between them. And YO and OU, they share O, so angle O is between them. So let's see if we have that true. We know that angle A is congruent to angle O based upon our figure. So let's do the math. So TA, 6, YOU, or YO is 8, YOU, that's funny. And then we have AG is 8, and OU is 12. Now, is this true? Is it true? We might need to make a correction really quickly, because I think this is, let's change this math right here really quick so that it is true. So 8 times 8 is 64. So we're going to need a number right here. Let's figure out what it has to be really quick. So 6x equals 64. We'll divide by 6. So x equals 10 and 4/6. So 10 and 4/6 and 4/6 is, I'm sorry, really quick in decimal form, really quick. That's 634. So it's 0.66666. So 10.6 repeating. And so that's what we would get there, 10.6 repeating. Did I do that right? I think I want to back this up. How about we just change the 8 instead? I think I'm right, but let's just change the 8 instead. So we're going to leave that at a 12, and we're going to change the 8. This is 3/4, so what's 3/4? This should be a 9. That is just so much easier. So let's go back and do TA is 6, YO is 8, and AG is 9, and OU is 12. And you can tell really quickly because if you cross multiply, that's 72 that direction, that's 72 that direction. So their ratios are congruent. So that takes care of your side and your side. Pardon for the mistake. And then their included angle, it's the angle that's between the pairs of sides, is congruent. So because that is true as well, we can say that these are similar triangles. Okay? So sorry about that mistake. Let's move on. So basically we have these theorems. We're going to put these into practice. So you're given a parallelogram. Here's your figure. Parallelogram ABCD is a parallelogram, okay? We're going to prove that triangle BFE is similar to CFD. So let's talk about what information inside of this parallelogram is going to give us information here that will help us to figure out congruency. Let's talk about possibly using, I don't think sides are going to help us here because we don't have any side measurements. So using opposite sides or congruent isn't helpful. Now, it might be useful to use parallel sides. Let's take a look at that. Let's see. Let's try saying AB is parallel to DC based upon this information, with DE being a transversal. Now, if DE is a transversal, and this is an extension of that parallel line right there, we can say that these alternate interiors, angles, there's your parallel lines, there's your Z zagging through, there's your transversal, that those two angles are congruent. So that gives us a pair of congruent angles. Now, that takes care of that. Then if you look here, you've got a pair of vertical angles where these two lines intersect. And that's angle-angle congruency. And angle-angle congruency proves similarity. So that's all we have to do. We just had to think about what information coming out of there was important, and it was the parallel sides giving opposite interior angles. So step 1, you got your ABCD is a parallelogram. You're given. Step 2, we said that DC was parallel to AE or AB. That doesn't matter. So AB and DC or DCA, however you want to do it. I guess we better use AB because it's a parallelogram, so we'll use AB. All right, so why? Because opposite sides parallelogram are parallel, all right? Now, from that, we decided that angle CDF, which is this angle up here, was congruent to angle BEF because if parallel lines, then alternate interior angles are congruent. So we have the pair. Step 4, angle CFD congruent, CFD congruent to BFE. Be careful when you name those. C corresponds to B. You'll notice they're in opposite corners. They're the one angle that we didn't mark. And be careful, all right? And that's because vertical angles, congruent. and that's an angle, and that's an angle. Now, the theorem that we talked about was angle-angle similarity. If we can prove two angles and a triangles are congruent, then the triangles are similar. So we're done. So triangle BFE is congruent to triangle, similar to triangle CFD through angle-angle similarity. Angle-angle similarity, and that was statements 3 and 4. Done. Finished. And as I said, you'll be using this one an awful lot. So make sure that you're focused on your new postulates and trying to find the two angles that could possibly help you prove similar figures, okay? All right, let's do another one. We're going to do a paragraph proof with this one. It'll be faster, it'll be easier because we were given midpoints and trisections. All right, so we're trying to prove that triangle pen is congruent to triangle POW. Not congruent, apologize. Let me take a drink. It's similar, they're similar. All right, here's our given information. LP is perpendicular to EA. All right, well, that you know is going to give us some right angles. So that gives us angles. That's helpful information. Then we have this. N is the midpoint of LP. Now, this is something that is really important to note. That makes those two congruent, and that will make NP half the distance of LP because a midpoint cuts a segment in half. So NP, which is this segment, is half the length of LP. So whatever this is going to be 2 of them. Makes sense? And then it says P and R trisect EA. I'm thinking we're going to use side angle side similarity, side similarity, and angle between them, okay? I think so. So if these trisect, that means that this is congruent to that is congruent to that. So if this is Y, and this is Y, and this is Y, this would be 2Y. So you can see, if I pull the two triangles apart really quick, I think I'll make them face the same direction here. So here's the little triangle. This is P and E. All right, we got a right angle, and we got an X here, and we got a Y there. And then if we do the bigger triangle, okay, from P to L, we decided that that was X as well, but putting them together is 2X. There's your right angle, and this was 2 Y's put together. So you can see, even though we don't know the numbers, we can prove that X over 2X is equal to Y over 2Y. Well, it's 1/2 to 1/2. So there's our similarity, or our equal ratios. All right, so now we're going to take all of that information and our angle information that comes out of here, and we're going to write a paragraph proof. And we're going to use side angle side similarity using our information. Okay, so first we start. Given our LP perpendicular to EA, that means that triangle EPL and angle APL are congruent right angles. I might as well, right angles are congruent anyways. So we'll just say that. So that gives us our angle portion. And then we can say if N is midpoint of LP, then NP is half the length of LP, So NP over LP is a 1 to 2 ratio. For every x up here, we go 2 x's down here. So we are proving there's one pair of sides that have a ratio. So that's a side ratio. And then we'll do the next statement. If P and R trisect EA, oh, sorry about that, EA, then we could say that EP is over PA, sorry, is also a half EP to PA. So 1y here, there's 2 y's here, so that's a 1 to 2. So they have that ratio. So there's our other side ratio. So therefore, triangle 10 is similar to triangle POW by side angle side similarity. Okay, and we got one more, and then we'll be done. And here's what we have for this one. So we have given that KH is the altitude to the hypotenuse. So that if it's the altitude to the hypotenuse, here's what we know. This is a right angle because a hypotenuse is the opposite of a right angle of a right triangle. No other triangles have hypotenuse, only right triangles. And altitude's going to form a right angle here and here. Now we're trying to prove that KHJ, which is this little one, KHJ, is similar to HGJ. That's the big one. Okay, so I just want to make sure I named them right. Okay, so that's what we're trying to prove. This little one versus the big one. Not the little one versus the medium-sized one, but the little one versus the big one. Notice that they share an angle, by the way, right away. If one angle is embedded in the other, they share an angle. So angle J and angle J, that gives us an angle, okay? And we also have another pair of angles. Isn't that already angle-angle similarity? I mean, they share that angle, angle J. They share that angle right there. See it? And that's a right triangle because of the hypotenuse, and the altitude makes the other right angle, and I don't even need that one, by the way. I don't need that one. They're similar. I'm done proving. I don't have to do anything else. So let's write our proof. We're done. Angle-angle similarity. Like I said, you use it a lot. So we'll start with KH is altitude to hypotenuse, to the hypotenuse. That's our given. Oh, to the hypotenuse of, oh, we got to finish this, of GJ, the hypotenuse GJ. I can't even read my own writing. Hypotenuse is GJ of the right triangle GHJ. Okay, H is where the right angle is, so that's that part. So that's our given. And where did we go from that? Well, we stated that we had a right angle right here, and then we need to state that this is a right angle down here, and that's going to come from this statement. So let's do the altitude first. So we're going to state that angle HKJ is a right angle. All right, so why is it a right angle? Because an altitude of triangle drawn to opposite side forms right angles. You could just say altitudes form right angles. That's fine. So that gives us an angle That gives us an angle. Now we're going to get the other statement, hypotenuse. So we're going to say that angle JHG or GHJ, whatever, is a right angle. Yeah, JHG is a right angle. And we're going to state why that's the case, because the hypotenuse is always opposite a right angle. And so we have not yet stated congruency, and we have to state congruency. So we would do statement 4, the angle HKJ is congruent to angle JHG because right angles congruent. So there's our angle statement. That is our congruent angle statement. We had to combine and say those two things. Now what we're going to do is say angle J is congruent to itself. Got to know that. There it is. It's in both of them. This little triangle was embedded in the big triangle, so always look for those. That's your reflexive property. And we're done. We can now state that these triangles are congruent. Triangle KHJ is similar to triangle HGJ through angle, angle, similarity, and that's statements 4 and 5. And that's all I got for you. So hopefully that helps, and it'll help us avoid spending a lot of time doing proofs through class. All right, have a good one, guys. Bye.